Hello class, welcome to the first topic of this first day of the propedeutic course. And this very simple topic is about similar triangles. And in Spanish, these are called triángulos similares o triángulos semejantes, aunque la palabra más correcta es similar. Okay, so what are similar triangles? Let's remember that the definition of similar triangles is the following. Similar triangles are those of the same shape but different size. For example, right here, I'm showing you two triangles that I tried to draw with the same shape, as you can see, but the only difference between them is the size. Okay, so they have pretty much the same shape, only difference is in the size. You may think that, for example, this little triangle is actually this one, but further away. Okay, this triangle is much further away, and so you're looking at the same triangle, one which is closer, and the other one which is farther away. But it's essentially the same triangle in regards to shape. Okay, that's the whole point. Okay, a more technical definition for similar triangles is this. Similar triangles are those with proportional sides. For example, what if I told you that these two triangles have the following sides? This side measures 1, this little side measures 2, and this side measures, let's say, 2.5. Okay, like so. Okay, so these are the sides of this triangle. And the sides for this other triangle, let's suppose that they are 4, 8, and 10. Okay, so you have these two triangles, they are similar, and a technical way or a more formal, more mathematical way to say or to demonstrate that they are similar is by looking at them and realizing that they have proportional sides. What does that mean? Okay, it means the following. This side is to this side, okay? 1 is to 4, as this side is to this side, right? As 2 is to 8. 1 is to 4, as 2 is to 8, okay? This side is 4 times this one. This side is 4 times this one, and this side is 4 times this one. Okay, so all the sides are proportional, one by one, this with this, this with this, and this with this, and therefore we conclude that these two triangles are similar. So that's basically the whole idea behind similar triangles. Same shape but different size. Okay, now as you must remember, I believe, there are certain criteria to know whether two triangles are similar. And those criteria are usually known as AA, or angle angle. Number 2, SAS, side angle side. And number 3, side side side. Okay, SSS. Okay, so what does this mean? It means the following. I'm going to give examples. For example, this criteria, the criteria for angle angle, means the following. If you have two triangles, I'm going to draw them. Okay, and if you happen to know that two of their corresponding angles are equal, for example, let's suppose that this angle is 40 and this angle is, let's say, 30, okay? And if this other triangle happens to have the same angles, okay? So both triangles have two equal angles. That's why this criteria is called angle angle. Therefore, these two triangles are similar. Why? Well, because it's clear that we can find the remaining angle, which is this and this, right? If this is 40 and this is 30, this must be 110, correct? And this one has to be the same, right? So basically, the two triangles have the same angles, therefore have the same shape, and therefore they are similar. So if two triangles have two angles, this and this, and this, two angles equal to one another, you can be sure that they are similar triangles. Okay, so that's for the first criteria. The second criteria, side angle side. How does that work in here? Okay, it works in this way. I'm gonna draw again two triangles, more or less with the same shape. I'm trying to draw them as though they were similar. Sometimes it doesn't work very well. There you go. Okay, now what happens if now you know the following about these two triangles? You know that they have one angle equal to one another. For example, this angle is equal to this one, and let's suppose it's again 40 degrees. Okay, so you know that they have an equal angle. And you also know that a pair of sides from the first triangle is proportional to a pair of sides of the other triangle. What do I mean? For example, let's suppose that this side measures 1 and this other side measures 2 units. And you know that this triangle has the following sides. For example, 2 and 4. Okay, I'm just making numbers up. Okay, so what can we know? What can we understand or realize about this pair of triangles? Well, they have an equal angle, okay, and they have the part of the side uh, is basically about a pair of sides in here having the same proportion as the other pair of sides. What does that mean? It means that this side is to this side 1 is to 2 as 2 is to 4. You see, this is twice this, this is twice this. So we have two pairs of proportional sides. That's why side side. And you have the angle in between them being the same angle, okay? So that's how it works. And if you know those two things, that they have an equal angle and two pairs of proportional sides, you can be sure that these are gonna be similar triangles. And the other criteria is basically one more time, basically this definition. If you know that two triangles, well, it's actually this. I already have it drawn here. If you know that two triangles have proportional sides, all of them, all of the sides are proportional, side, 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 then you can be sure that they are similar, which is this case, okay? All of the sides, you don't have any angle in here. You don't know the angles yet, but you know the three sides of this triangle, and you know the three sides of this triangle, and you know that this is to this, as this is to this, as this is to this, okay? So all the proportionality is conserved, therefore these two triangles are similar, side, 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 and that is the last criteria. So we have three criteria. You can use any of them in order to know whether two triangles are similar, and that's it basically, okay? It's a very quick reminder for similar triangles.